Good morning, my YouTube viewers. In this particular video, what we're going to be doing is we're going to be doing a practice question on hypothesis testing with regard to water consumption. So the question is, you have a sample of 25 measurements of the daily water consumption of a city with a mean of 120 liters per household and a sample standard deviation of 15 liters. Test whether the mean water consumption is significantly different from the 120 liters at a 115 liters at a 5% significance level. So we're going to answer this question using Python. So in order to use Python, what we need to do is we need to import 3 libraries that we need to execute the program. So we're going to import NumPy as NP, which is a numeric library. We're going to import SciPy.stats as stats, which is the statistical module of SciPy, and SciPy is a scientific library. And we're going to import matplotlib.pyplot as PLT, which is the visualization library. So now what we're going to do is we're going to define our variables. So the sample mean is 120, the sample deviation is 15, the sample size is 25, and the hypothesized mean is 115, and the confidence level is 95%. So the first thing we're going to do is we're going to generate our random data, generate our sample data. And we need to do that by setting our seed. The reason why you set your seed is because you want to initialize the values. So every time you run the program, it will start up with the same values. So that's np.random.seed and brackets any number that you want inside the brackets. So we set up our sample data as np.random.normal. And so normal means it's a normal distribution. Brackets log equals sample mean, that's your mean. Scale equals sample STD, that's your standard deviation. And size equals sample size, which is 25. Now what we do is we perform a one sample t-test. So t-statistic, p-value equals stats dot t-test one sample, brackets sample data, brackets hypothesized mean. So we also calculate the confidence interval. So confidence interval equals stats dot t dot interval, brackets confidence level, comma df equals sample size minus 1. So that's going to be your degree of freedom equals 24. Log, that's your sample mean, and scale equals sample deviation divided by the square root of the sample size. So now what we're going to do is we're going to print our results of the t-statistic, the p-value, and the 95% confidence interval. So your t-statistic is 0.89, your p-value is 0.3835, your 95% confidence interval is 113.8 to 126.2. So your p-value is greater than alpha. I think it is generally greater than 0.05. And so since it's greater than 0.05, then they're going to fail to reject the null hypothesis. So it fails to reject the null hypothesis. So now what we're going to do is we're going to plot everything out on a graph. So plt.figure, brackets fig size equals 6,4. And then we're going to create a histogram, plt.hist brackets sample data, comma, bins equals 10, comma, color equals blue, comma, edge color equals black, comma, alpha equals 0.7, comma, label equals sample data. And then we're going to put up a series of vertical lines on top of the histogram. So plt.axv line, brackets, confidence interval 0, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals lower band, confidence interval 0 liters. plt.axv line, brackets, confidence interval 1, comma, color equals red, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals upper band, confidence interval 1 liters. Now you have AXV line, brackets, sample mean, comma, color equals green, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals sample mean liters. The last line is plt.axv line, brackets, hypothesized mean, comma, color equals purple, comma, line style equals dashed, comma, line width equals 1.5, comma, label equals hypothesized mean liter. And so now what we do is we label our graph. So the X label is daily water consumption liters. The Y label is frequency, and the title is histogram of sample water consumption with 95% interval. You get a title, you get a grid, and we're going to show it. So here's the histogram that we have created. So you can see the blue bars are your sample data. The red line is your lower bound and your upper bound. So your lower bound is 113.81 and your upper bound is 126.19. The sample mean is 120 and the hypothesized mean is 115. And you can see that the hypothesized mean falls within the lower bound of the confidence interval. So since the hypothesis mean falls within the lower bound of the confidence interval, that means that you have to accept the null hypothesis. And that is proven because your p-value is 0.3835, being higher than 0.05, even though the p-value hasn't been defined in this particular program. But what it does say says if hypothesis mean is greater than confidence interval 0 and hypothesized mean is less than confidence interval 1, print fail to reject the null hypothesis, else reject the null hypothesis. So it works out that way. So that concludes this video on the water supply. So the next video we're going to be doing another practice question. So thank you so much for watching this video.